So yesterday I showed some functions related to polylines, how to use polyline functions, and some functions related to wireframes, meshes. So today I'll continue showing the functions related to wireframes because yesterday we didn't finish. And once I finish with the functions, wireframe functions, we'll go further and I'll show how to visualize or how to load drill holes from files, then how to make sections, how to do compositing, and do some explicit modeling. I mean the modeling by those grades, by joining those grades into contours and create ore body from contours, then create block model from generated wireframe. So first of all, we'll continue with mesh functions. Okay, for this purpose, yes, today I will show Boolean operations on mesh, on wireframes. So for this purpose, first we'll create some DTM terrain model. Okay, I'll open points. So these points are terrain model points, point cloud. Okay, I think Muhammad is joined. So in order to create DTM, we'll just select all these points, and using this button, we'll create surface from selected points. So DTM is generated. Now, just to make sure that DTM, the generated mesh is valid, we will clean it up. So okay, we cleaned up. Now we will create some contours, and we'll from that contours we'll create another surface, another wireframe. So for this purpose, let's create here toggle reference plane. In order to toggle, as I showed yesterday, you can just draw this line, one line, and right button click. So will be toggled reference plane. So reference plane is toggled on this level, on this elevation. Okay, make it more transparent, and we'll start to create some contour. Okay, let it be here. You can see, right? So for the time being, I'll make it just invisible. Yeah. Now, this. Okay. Now this contour, we will project for this contour, this polygon, horizontally and vertically in order to create some more contours. Let's put it some offset, horizontal offset, let's be 15 meters, and vertical offset, let's be 20 meters, and we'll create 8 more polygons. So polygons are created. Now I can unpin the reference plane. Polygons are here. Now let's create surface from these polygons. So this button, you can see buttons, right? So first button, it will create surface from these contours, from selected contours. Okay, yeah, we've created surface. Now this bottom polygon needs to be also triangulated. So for this purpose, we will use this button. So this button will triangulate closed polygon. Yesterday I already demonstrated, right? So today we'll use this button. So there is a 3 option: standard and minimum area. So for 3D polygon, yeah, it's better to use this minimum area option. Yeah, it's transparent, but the wireframe was created. So we'll just change mesh color. So you see this we've created 2 wireframes, 2 separate wireframes. Now we need to merge these 2 wireframes. In order to merge, just we'll select 2 of them, and this button merge meshes wireframes. Okay, now it becomes as 1 wireframe. We'll make visible this our DTM, so you can see, right? And just move our newly created object a little bit up, just to make sure that our mesh Boolean operations are successful. So polylines will make it invisible. These 2 meshes are created. Now we'll clean up this newly created mesh, and we need to check the correctness of the normals. So for this wireframe, normals are directed inside, so that should be fine. That's okay. And for the DTM, normals need to have up directions. So here normals are headed down. Now we need to switch this normal. So for this purpose, so this button will invert normal's direction. Okay, now normals are correct. So everything is correct now. And once our wireframes are ready, so now we will start to do some Boolean operations. So before doing some Boolean operations, let's create here one more layer, mesh layer. And so this layer currently, this layer is empty. This is empty layer, right? So we'll make it active, and we'll copy these 2 mesh from these 2 mesh. We'll copy it into the active layer. Just select the 2 meshes and copy to active layer, because we'll later need this meshes. Okay. So here is a copy of the our meshes. Now, in order to do Boolean operations, we need to select two mesh, two wireframe. First of all, this one, okay, will be first wireframe A, and this will be the second wireframe, second mesh. And there is this button, the Boolean operations. Boolean operations, wireframe intersection operation. There are several of these options, right? So let's get the inner part of the inner part of our DTM. So for this purpose, this second function, we'll use second function. Okay, let's A, B, inner part A, because the first one was A, right? Yeah. A and B. Part. Yeah, that means normals wasn't correctly set. So in this case, we'll just choose outside part B. So it will just consider that the one that's inside or the one that's outside depending on the normals. So this is a inner part that are inside this our wireframe. So that's why setting normals is one of the important operations. So in order to get proper path while you do mesh Boolean operations. So now let's try to get the combination of these two wireframes. So subtraction B minus A will get this. So the volume that is captured with, inside our pit, simulation of the pit object. And intersection. So this is the intersection. Yeah. So this is a Boolean operation that Boolean operation of two meshes that are not closed. So if meshes are closed, one of them closed. So the result will be a little bit different, but you will get almost the same type of objects. Okay, and last one, just to check what we will get. So this is a union of that operation, mesh Boolean operation. So if you have two solids, I mean solids means closed, watertight meshes. So results also will be a little bit different also, because for solid meshes, normals actually automatically will be calculated correctly. And for open, not closed meshes like this, right? So normals always it will be some ambiguities, and user need to solve those type of ambiguities if you want to get proper results of the mesh Boolean operations. So this is about the mesh Boolean operations. Now we'll go further, and our later further functions will be working with drill holes, so loading drill holes from files. Okay, for the time being, let's clean up all this stuff and make this one available. So these toolbars are related to loading drill holes. So this one is load from server, but Dolon.pro there is no server, so it won't get anything because no database management system is available here. So we will use a second function. The second function is loading data from file. So in order to load drill holes from file, we need two type of files. First, color file. I think you have already used this type of files in Micromine or in SIRPAC. So this same type of files. Currently, Dolon can open files from CSV format, also from DAT format. If you have some Micromine DAT files, you can open directly here in Dolon. So I'll use CSV files. The format of the CSV file yesterday I've shown. It's this simple, very simple format. So these are the fields, hole ID, depths, and north coordinates. So this for color file, and so if field names are standard, that means hole ID, depths, east, north, array, all x, y, z. The system will automatically put those fields into their appropriate place. I mean the mapping will be done automatically. And for survey file, the same thing. If you have some naming of the field is different, let's say not hole ID or pH ID or something like that, you will need to map it manually just by choosing from these fields. So once fields are mapped, we will download it. So file, these two files are one file contains color information, and second file contains survey information. So from these two files was generated these drill holes. Now if you have assay files, some interval files, so those interval files, interval data also can be uploaded here, shown here. So for this purpose, we'll choose drill holes layer. So one drill holes layer is active. So these are properties of this drill holes layer, and properties of the single object. It will appear on the right side. So in this layer, there are 36 drill holes here, and these are the configuration for the whole layer. Now we will load interval file. interval file. I have appropriate interval file, the assay file, and on the assay file I have the grade information. So these are the whole ID, from to field, and grade field. So all data is loaded. Now I can visualize those assay data along the drill holes. For this purpose, there are two ways. One way is just directly color along the drill hole traces. Let's put here grade. So this grade was loaded from the file, assay file. So we'll choose this, and legends. I have predefined legends. So for you, you need to create these legends. So legend can be created using by this point. So this point will, this button will open this form, and if you have any available legends, they will appear. The list of the legends will appear here. If you don't have, you will just click on this plus button, and you can create here legends. So legend name, I will just show how to create some legends. So test, let's be it test 2, additional information. If you have some additional information, you can put it here. And this is a color. It can be automatically, we can just select from this spectrum, right, from this range, so it will automatically arrange it. If you need, you can put by just clicking this button will add new row if you need, and put here some values. Let's say from 0 to 1. Equal to 1 means from 0 equal 1 is included. Let's be it red. From 1 to 5, let's be green. From 5 to 7, 8, let's be a little bit this color. And from 8 to 15. Yeah, I've created new one, so you can create by yourself the new legend. And yeah, here I'll use the legend I've created previously. So I put it here, test 1, and then show sampling results. So this button will apply those legends onto drill holes trace. So drill holes trace will be colored depending on the data loaded from assay file. So if you want to remove it, just by clicking this one, this will remove it. So this one will apply it along drill hole trace. And if you want to show labels, so labels can be configured by clicking this button. So this button, so you will create, let's say, let's delete all this predefined data. So we'll create new one. Okay, that's risks and grade factor. Let's be 1. Color legend. So I will use test 1 and default color. Okay, let's be this color. factor source. There's a grade. The grade was loaded from a save file. Field source also, let's be grade. And this is appearance on the left side. Let's see, and we'll update it. Yeah, so this is for shading chart lines, and for interval table we'll show we'll choose data source, color legend, default color. Okay, let's be white, and alignment right, position is 0. Okay, now so this is our labels. So you can see, right? So this I've applied color legend along traces also, and for labels also. So there is another button that's compositing. So compositing will calculate composites. Okay, let's we need to set up some options. This for composite for grade, minimum grade, or sample grade minimum, and length or length minimum or length, and maximum waist length. Okay, let's be it this way, and load assay data will load the same assay data. Grade is same grade, and compositing it will create and added composite points. So composite points you can see here now. These are composites that were calculated. So this beginning of the composite, this middle, and this end of the interval. Yeah. So this is how we can work with, we can visualize and apply assay data along drill holes. Now let's try to do some explicit modeling. For this purpose, we can use composites. We've already calculated composites, so we'll remove those sampling results just to make sure that these composite points are clearly visible. And we can now create section. So in order to create section, yeah, we can switch to the section panel. These are sections panel, and this button will set section. So that section we can set okay from let's start from this point, right? And we can set the towards and away options. So we can set it 5 and 5, or 10 or 10. Okay, let's or 15 and 15. Okay, so let's speed 15 towards 15 and away 15 meters. So overall step is 30 meters. Yeah, this our section, and this one will set the section, and here will appear section properties. Once section properties is appeared, so these are the tools that help to move to previous section or to the next section. Now let's create some let's do some explicit modeling, right? From this composite points, we can create contours by using this polyline tools. Okay, so snap to points will enable snapping. Activate this tool and start to join this composites by line, and it should be somewhere here. Okay, so we've created this one, right? Okay, now we'll move the next section. So for this section, okay, for the previous section, we forgot this one. Maybe it will be something. Something like this. Let's toggle reference plane. So these are just for demonstration purpose. So this was for this section, and we'll move to next section. And for this section also, first let's create toggle the reference plane. Okay, just let's toggle it. So I've toggled because I will use this this plane. So for this purpose, we can actually use several points of drill holes. From these drill hole points will be created plane, and this plane will be used as a reference plane. And we can draw these our polygons. Let's move to the next section. Yeah, so in this way we can create a lot of polygons, and those polygons will be used later to create our body. Okay, I have toggled plane. Let's create one more contour. The purpose is just to create by using these contours or body. Yeah, I think it's enough for now. So you can see, right? Now, from these contours, we can create all bodies. So this is one more body. That is one a second one. I think it's better to connect with this one. And now we need to maybe just to make it's more correct, we'll just copy and a little bit shrink it and make one more wireframe, and we'll merge it. Now we'll close this wireframes. So for this purpose we'll use this button. It closed, and you can see here closed and volume for this one also. So this we'll close it. We'll close it, also has a volume. So now our bodies are ready. So this is just a sample example for example, and there is another tools to work with wireframes, to modify wireframes. These tools help to modify wireframes. Let's say for this one, right? If you need to modify to edit wireframe, and if you know that the shape of the ore body won't be a little bit different, so we can select this wireframe and enable wireframe edit mode. Once wireframe edit mode is enabled, we can delete by using this button, delete let's say triangles. Okay, let's delete this triangle. These triangles. Yeah, and if you need to create some other triangles, so we will just put new triangles. So let's connect it in this way. Okay. So we've modified our mesh. Once we finished with modifying, we'll close enable mode, so it will suggest us to save edited object. Okay, and so this one is now modified our body. So once it's modified, compute volume, it will compute once more, and this is a new volume. So this is we've created our body. So far so good. Do you have any questions?
Yes, good, no question.
Okay, okay. Now, once we have this our body, now we can create block models from this to our bodies. So in order to create block model, first from here we'll create block model layer. Once block model layer is created, it will automatically detect all meshes which are on the scene, and will automatically try to define extents. So actually we can create for every ore body different block models, or we can create for all these ore bodies just one block model. So for the time being, let's create two different block models. So the first one we will create for this for first upper ore body. For this purpose, we'll select this one and this button. So this button belongs to block models properties. By clicking this one, it will automatically tries to calculate the extent of this selected wireframe. Once its extent is selected, so we can, okay, just to make sure to see size, right? So this is around 28 meters. Okay, around 100 meters, about 20 meters high. So we will create, we will set block size, parent block size. For the block model, first we need to, for extents, we need to configure parent block size and sub block size. So parent block size, let it be 5 meters. 5 meters, this is size, X, Y, Z size. And for sub blocking, 1 meters. So we set extents parameters. Now here we need to generate block model from a selected wireframe. So block model, let it be or intersection options. That means when it generates blocks, so it will take into account block bounds or intersection with wireframe, or all center, just the blocks that center points are only inside the ore body. So let's select this one, and there is two options to generate block model. One is used by GPU. I think you are familiar with GPU. This is not the CPU. This utilizes performance of the video adapter. So optimal sub-blocking, this one uses CPU. This not GPU. So let's, for the time being, just select this one and source of mesh from the SAN, and we'll generate block model. Yeah. Okay. So now you can see, right? Block model is generated. So this block model generated for this one. And for the second one, if you want to make separate block model, so we need to create another layer, and for this layer, yeah, we will use its own extent parameters. For this one, let's also make it 5 meters, and sub-blocking is 1 meter. And we'll configure block model settings, block bounds, optimal source mesh from the SAN, and generate. Yep, and it also generated. So we've generated 2 block models. Now, once block models are generated, now we can we can estimate all resources. In order to estimate all resources, so for these block models, for each block model layer, each one has its own method, the resource assessment by IDV method. Currently in Dolon, they've implemented resource estimation by IDV method. By Kriging, yeah, we haven't implemented yet. So this on the way. So we are developing currently. Okay, let's do some estimation process. So for this purpose, we need to select the SA file, because we need to show where it's need to get the grade information. So this is the grade information from this file, and this parameters of the search ellipse parameters. So search ellipse parameters, I have here some settings. So these settings are strike 15, polarity -1, 15, -1. Okay, radius let's be 10 meters. Sectors 4. Okay, something, it says something is wrong here. Ah, yeah, I didn't put here coordinates. So coordinates are now here. Created there. Okay, let's see. Is there any drill holes that are going through this ore bodies? Yeah, there are. Okay, let's try once more. X, Y, mid Z. This grade.
Mr. Taimur, I think you didn't select the grade in the input data.
Great.
Yes, you have to select.
You mean actually, yeah, that was automatically, that was supposed to get automatically. Okay, let's start once more. This factor is fine. Okay, something is, let's yeah, something is missing on my files. So okay, I'll need to check my data from SA file. So anyway, this was supposed to, okay, these are fine, these are fine. Attributes are there. Bodies are there. Okay, once more. Okay, maybe on just number per sector 100, maybe. Okay, 15. Search. Okay. Okay, I need to validate my SA data. So SA data, it says here SA data is not valid. Okay, anyway, so if valid SA data is provided, so SA data that is loaded for the calculation process, so I mean from here, this one, and these coordinates, they need to be valid coordinates and valid SA data. Okay, let me just check. Okay, you see, this SA data I don't have coordinates here. You can see, right? So the coordinates are empty. So the coordinates needs to be there. If the coordinates are there, the calculation will be carried out. So I need to prepare coordinates and put the coordinates into my SA file. Yeah, okay. It's my fault before calculating, before carrying out. I needed to check if the coordinates are there. So this is for block model estimation by IDD method. We can okay, let's try another database for this purpose. For the time being, I'll just make them invisible. So this is another ore body. This ore body was created earlier. So we can use this one, and let's generate new block model, and let's set extents here. 5, 5, 5, 1, 1, 1. Block model or intersection block bounds. So from the sun, and we'll generate it. So this block model is generated. Now once block model is generated, we can use a save file. So this is a file. This one is correct save file. So yeah, it has coordinates. Since it has coordinates, the calculation needs to be successful. So we'll leave it as is. No, what's going on? It's not so well. Okay, just to make sure. So block model there. Now okay. Yeah, something is broken here. I need to check what's happened there. So I think I need to check what's broken there, and I'll fix it, and I think maybe I'll demonstrate it, yeah, tomorrow or maybe next week. So these are the or estimation by IDV method. And by the way, we have our own tool to calculate or to generate ore body automatically. So this one, this actually a little bit bigger function. So I think for this function we will need a little bit more data and a little bit more time. So maybe next week we will continue, and I will demonstrate the capabilities of this new our own algorithm. So this algorithm is like implicit modeling. So just now we've created ore body manually, right? So these tools help users to create those ore body automatically, not by hand, just by setting some settings, set options. So it will generate ore body depending on the trend, so on the general trend. So I'll show features of these functions in our next session. Okay. So if Do you have any questions? Hello?
Hello, no question.
Okay,
Great, Mr. Saab. Thanks a lot.
so for the,
Mr. Saber,
yep,
are there any help file inside this system, you know?
sorry, once more.
Help file
Ah,
inside the system.
help file.
Yes.
For the time being, yeah, we don't have help file. We just have this video tutorials, and you've already recorded this video, right? Yeah, if you recorded this video, you can, for the time being, you can use this video. And if you have questions, actually, you can ask directly, write directly to me. If I'm available, yeah, I'll help you. I'll explain you. And help files or manuals, they'll come a little bit later. Because these tools are very rapidly developing, right? And there are some new features are added very quickly. That's why writing manuals, the manuals will be a little bit old. In some time, they won't be actual. So that's why first we want to somehow finish all these features, functions, and summarize and prepare for more valid help files, manuals. Okay, if you have questions, just directly write to me or ask me. I'll explain, I'll show, I'll help you. Okay.
Okay. What about the next lecture?
Next election, I think I need to first of all tomorrow check what's happened there, or what's broken here, and prepare some proper data, proper files for this outer wireframing tool, and I think that it will be on Monday. Is it okay for you?
Okay, that is great. Okay, thank you. Thank you, Mr. Saber.
Okay, thank you too. And you need to use these tools. You need to